I want to talk about the kinetic theory of gases. So to do that, I'm going to use a super ball, which bounces nicely. But this is still way too big. I mean, gases are filling this room right now. Trillions and trillions of particles. So they're extremely small. So the kinetic theory of gases, we're going to focus in on one gas molecule and describe the way it moves. You may have already done it in the lesson. If this is a super ball, and I'm going to bounce it, you can see how it travels. And I want you to describe how it travels. And notice it hits the floor, it's hitting the ceiling and coming back down again. Back down and up. Imagine if this had a perfectly elastic collision. And that's what I wanted to bring out in this demo. Gas, we're assuming with the ideal gas law and in the kinetic theory that gas particles behave perfectly, which means they have perfectly elastic collisions. So when I bounce it on the floor, actually it would bounce off the floor and come back up with 100% of the energy that it went into the floor as. Of course, in real life, that doesn't really happen. Describe the kind of motion that you experienced there. Well, you'd notice it was straight line, right? That it was random. I mean, if this is a container where, you know, the gas molecule would keep moving, eventually it could bounce all over the place, very random, and it would continue to move as long as it is perfectly elastic. So let's try it again. This time I'm going to see if I can put a hole in the ceiling. You ready? What happened? Oh! I think it's my chemistry students. They killed my ball.